Okay, hello everyone and welcome to acid-base revision. It's mostly going to be about pH. Okay, so first of all I want to give you just a little bit of an overview of pH again and just a reminder. Now the main thing that you need to remember is that water has this intrinsic property in that it is amphiprotic, so it self-ionizes naturally. Now, it does so to a different extent, whether it is at a low or a high temperature, but we'll just talk about at 25 degrees Celsius. So, at 25 degrees Celsius, water self-ionizes, just like it does at any temperature, into H2O plus and OH minus, which are hydronium and hydroxide. But it does so to a very small extent, otherwise water would be very conductive, pure water. So these have a very low concentration. Now they've experimentally found that the product, that is the concentration of OH minus times the concentration of H2O plus, equals 10 to the negative 14. These talk about concentration in mole per litre or molarity. Okay, so we may talk about an acidic solution, we may talk about a basic solution in a number of ways. When you add an acid to water, what happens is it reacts with water to produce Cl minus and H2O plus. This is a strong acid and will completely ionize in water. That means you'll only have these left. So an acid increases the concentration of H2O plus. It also decreases the concentration of OH minus because it reacts with OH minus as a base to form water and the conjugate base. Remembering that at 25 degrees, if this one increases, that one has to decrease to equal 10 to the negative 14. Now an acidic solution for that reason has a concentration of H2O plus which is greater than 10 to the negative 7, and it has a concentration of OH minus which is less than 10 to the negative 7 molar, that is. Now a basic solution is different, because what a basic solution does, let's say CO3 2 minus, reacts with water, this is a weak base, to produce OH minus, water will donate its H, and HCO3 minus. Similarly, it will react with H2O plus, because that's a strong acid, it will produce H2O plus HCO3 minus. So in the same way, bases increase the concentration of OH minus and decrease the concentration of H2O plus. Now, a base will have a concentration of H2O plus, which is less than 10 to the negative 7 m, if that's pure water. And will have a concentration of OH minus, which is more than 10 to the negative 7 m. Okay, so we can talk about acids, like for example, if something has a concentration of H2O plus equals 10 to the negative 4 m, we can say that that's acidic, and something which is H2O plus, which is 10 to the negative 12 m, that is basic. But this got a little bit tedious with the low concentrations because they're at such a low concentration that they introduced the pH scale. Now the pH scale, the point was to remove the 10 to the power of and to remove the negative. So what they did is they brought it on a negative log. So pH of anything equals 10 to the negative log, and negative log 10 concentration of HO plus, and POH, so if we take the negative log of this, negative log of that, and negative log of that, we get pH plus POH equals 14 at 25 degrees Celsius. Another little thing is going from pH back to concentration of H0 plus equals 10 to the negative pH, and concentration of OH minus equals 10 to the negative POH. So pH of less than 7 is basic, and POH of less than 7 is basic. Sorry, this is acidic, that's basic. POH greater than 7 is acidic, and pH greater than 7 is basic. So they're just like mucking around with a few relationships. Hope that helped. Okay, so let's have a look at the first question. So it says 250 ml of HCl is placed into a beaker. The volume of water needed to be added to the beaker to dilute the HCl is what? Now, the important thing to remember is when you're diluting an acid, you are decreasing the concentration of HO plus, but it will be increasing the concentration of OH minus. When you're diluting a base, you decrease the concentration of OH minus, and it has to keep equaling negative 14, so it has to increase the concentration of H plus. So for this type of question, you would do C1V1 equals C2V2. So we're diluting an acid, so we're decreasing the concentration of H plus. So the C1, the initial concentration of H plus, equals 1.25 m, because HCl breaks off into 1H plus. C2 equals 0.5 m. V1 equals 250 mils, and V2 is what you're trying to find. So V2 equals 625. Notice that it's there. It doesn't say what's the final volume. It says how much water needs to be added. So we have to subtract V1, which is the initial volume, equals 375 mils. So that gives you B. Okay, question 2. 5.65 grams of pure sodium hydroxide is completely dissolved in 100 mils of water. Calculate the moles of sodium hydroxide. Well, N of NaOH equals CV, mass over molar mass in this case, 5.65 over 40, 0.141 mole to 3 sig figs. It says calculate the molarity now. Now for the molarity, we are doing concentration equals N over V, 0.141 divided by 0.1 equals 1.41 molar. Now it says calculate the pH. Now for the pH, you need concentration of H3O plus, not concentration of OH minus. But with the concentration of NaOH equaling the concentration of OH minus, we know it equals 1.41 m, and we can work out the POH through that. equals negative 0.15. It's weird to have a negative, but the pH scale sometimes extends beyond 14 and below 0. pH equals 14 minus POH equals 14 minus negative 0.15 equals 14.1 to 3 sig figs. Wow, very, very basic. Question D. In another reaction, 3.58 grams of zinc metal is dissolved into 50 mils of 1 mole of sodium hydroxide. According to the following equation, okay, which reactant is in excess and by how many moles? So to work out which is in excess, we're just going to pick a random known. It doesn't matter which one it is. You could even spice things up and do it with the other one. See if you get the same result. You will. Then we work out the moles. We just pretend it's a known. Mass over molar mass, 0.358 over the molar mass of zinc is 65.4, 0.00547. Then we work out the moles of NaOH expected through the mole ratio, which is 2 to 1. Equals 0.0110. Then we work out the moles of NaOH actual, and it equals CV equals 1 times 0.05 equals 0.05. So then we go. We've actually put in a lot more than what we expect, so that means NaOH has to be in excess. How much will be left over? Well, it's like in the back titration. NaOH left equals NaOH initial minus NaOH reacted. And that's pretty simple because you have the initial amount there and you subtract what you expect because that's how much will react because it's in excess. And then you get 0.0391 mole. Which reactant is in excess? NaOH by 0.0391 mole. And to 3 significant figures. Then it says calculate the volume of hydrogen gas produced. Well, we've got to use the limiting because that will limit how much is produced. So we work out the moles of the H2 using the moles of zinc. Equals the moles of zinc equals 0.00547 mole. Then we do PV equals nRT, and we are trying to work out volume. So equals 0.00547 times 8.31 times temperature, which is 32 plus 273, divided by 105.5, and that gives us 0.132 litres, which actually equals, because we need to have it in mils, 132 millilitres. Okay, just a few more questions to go. So the next question says, what mass in grams of anhydrous sodium carbonate is required to neutralize this particular amount of ethanoic acid? So first of all, you're going to have to get the mole ratio by writing out the equation. And we have to balance, and yes, it's a 2 to 1. So what we need to do is first of all work out the moles of our known equals CV 0.5 times 0.1, 0.05. The moles of sodium carbonate equals a half. The mass of sodium carbonate equals moles times molar mass. Plug all that into your calculator and you should get 2.65 grams, which is A. Now I can assure you that with the other answers, if you had a 1-to-1 mole ratio, you would have gotten it. Okay, STAB 2014. So this is quite a tricky question. So it says here, oxalic acid is a dicarboxylic weak acid. So it has these groups. Okay, and that's 2 times these groups. Now you may already notice that HCO2 is 1 carboxyl group. So because it's exactly double that, it's actually only made of 2 carboxyl groups. So when they say draw it, it's quite easy because you just have to have 2 carboxyl groups joined together. Then it says write the 2 possible ionizations. Well, we know that it's diprotic. So we need to do 2 separate ionizations, and it says it's a weak acid, so we need to have those equilibrium arrows. So C2, we'll just write it out in the same way that it's shown. O4 plus H2O, weird arrows, loses 1 H and makes H0 plus. Then with the other one, add H2O, plus H0 plus. Determine the oxidation number of Fe in FeC2O43. I'm going to do that down here. So FeC2O43. What a strange question. Okay, so C2O4 must be 2 minus because once it's lost both of its H's. Now there's 3 of those, meaning that we have -6. Okay, now Fe is not +6 because it doesn't equal 0, it equals -3, so it has to be +3. Okay, now the other 2 questions are sort of titration ones. Have a go at them, see how you go, but we want to stay on the pH topic. So this question, last page, 4 more questions to go. What is the pH of 0.05 molar strontium hydroxide? Okay, well first of all, we know the concentration of strontium hydroxide, but we can't just do negative log of that because pH equals negative log concentration of H plus, not concentration of strontium hydroxide. So it equals 0.05 molar. But we can get there because we know that the concentration of OH minus has to be 0.1 molar because strontium hydroxide breaks down into 1 strontium and 2 OHs. So we can work out the POH, negative log concentration of hydroxide, negative log 0.1 equals, negative log 0.1 is 1. pH equals 14 minus POH. 14 minus 1 is 13, giving us D. Okay, a 25 ml sample of a diprotic weak acid is titrated with 20.2 ml of NaOH. What is the concentration of the acid? I always do this when it's a diprotic acid. I just write H2X, or you can even write H2SO4 because they don't really mind like what the spectator is. So let's just write H2X plus NaOH just to get the mole ratio, and that has to be minus 2. It's even easier, look, if you just write H2SO4, it makes it a bit easier. This is a 2 and that is a 2. So first we have to work out the moles of NaOH equals CV 0.1 times 0.0202 0.00202. The moles of H2SO4 equals 1/2 times 0.00202 equals 0.00101. Then you can work out the concentration equals N over V, and the volume is 25 mils. So 0.00101 divided by 0.025 equals 0.040, which gives us option A. Okay, second last question. What is the resulting pH if 25 mils of barium hydroxide is added to 25 mils of HCl? Well, first of all, let's write out the equation. You've got a dibasic base with a monoprotic acid, so you're going to need twice the number of moles of acid. But I'll prove it to you through the equation. Yep, okay, so 2-to-1 ratio. You can already tell that if you've got 25 mil, if you've got the same amount of moles of each, and you actually need twice the number of moles of HCl, its HCl is limiting. So it's going to be basic, so it's going to be one of these two. But let's have a go anyway. Number of moles of HCl equals CV, we'll just pick one, 0.1 times 0.025, 0.0025. Moles of barium hydroxide expected equals 0.00125. Moles of barium hydroxide, actual equals 0.0025. So therefore barium hydroxide is in excess, and you've got to find out by how much. So the moles of barium hydroxide left equals 0.0025 minus 0.00125 equals, and we'll just take up this space, 0.00125 mole. Now the concentration of hydroxide, or the concentration of barium hydroxide, equals N over V, 0.00125. And now the volume is not 25 mils because you've added the two together, so it's 0.05, sorry, equals 0.025. That's right, isn't it? Yeah, mole. No, molar. the moles of hydroxide equals 2 times 0.025, because you have 2 of them in there, 0.05. POH equals negative log 0.05 equals 1.3. So pH equals 14 minus 1.3 equals 12.7. So that was a little tougher, okay, a bit of a tougher type question, but it doesn't mean you can't do it as long as you follow the basic principles. Okay, the next question I'm just going to highlight so I can actually see it in this mess. Okay, so what volume of water is needed to be added to 10 mils of sodium hydroxide at a pH of 12.3 to dilute it to 10.2? Okay, so when you dilute a base, you actually decrease the concentration of OH minus. So we have to work with that. So the concentration of the POH initially equals, because we want to use C1V1 equals C2V2, initially equals 12.3, so 14 minus 12.3, which is 1.7. POH final equals 3.8. So that means, POH, yes. That means the concentration of hydroxide, C1, equals 10 to the negative 1.7. Concentration of hydroxide, C2, equals 10 to the negative 3.8 molar. Okay, and then this is 0.01995, and this is 1.6 times 10 to the negative 4, and then V1 equals 10, V2 equals question mark. So we'll just set it up. C1 V1 equals C2 V2. So C1 equals 10 to the negative 1.7 times V1, which equals 10, equals 10 to the negative 3.8. Why am I writing these ones down where I could just be writing the simplified or the calculated one? V2, so V2 equals, 1258.76 milliliters. That's not the volume of water added. We need to minus water added minus V1, which is the initial volume, is 10 equals 1248.76. And we need to put it to 3 significant figures, which is 1, or you could turn it into liters, which equals 1.25 liters. Okay, so I hope that helped consolidate a little bit with pH, but make sure you keep doing more and more questions.